If you're given an opportunity to pull out a greatest common factor, do it. If you're given an opportunity to pull out a greatest common factor, but then there's still more that can be done, like in this case, do it. Until you get to a point where nothing other than a 1 can come out, you're not done. So greatest common factor, difference of squares, and perfect squares are the things you learned up till lesson 5.6. But starting in lesson 5.7, we're like Star Trek entering unknown galaxies. What do we do if none of those components seems to work? And I am going to show you several examples, and you are literally going to have to practice this a bunch of times. Do them with me, because the pattern I'm teaching you is something that's best memorized. X squared plus 16x plus 28. Take this for example. So, is there a greatest common factor that can come out of all three? No. Is this the difference of two squares? No, Mrs. Myers, it's a trinomial. Is it possibly a perfect square? Let's check. Is the first component a perfect square? Yes. Last component? No. That doesn't mean you're done. That means you move on to this new uncharted territory that I'm about to share with you. Okay. Step 1. Separate your trinomial so that the first component and the last component kind of are down on a separate line. And you might come up with your own little way of doing this, but this is kind of how I explain it. A trinomial that is in this form is called a quadratic. And it is best identified, remember how they do A, B, C? Well, it is best identified as ax squared plus or minus b times x plus or minus c. Okay, it could be a positive or negative. Okay, so from here on out, you're going to hear me talk about things in the quadratic position, that's the A, the linear position, which is the B, and the constant position, which is the C. We identified those components a while back, but in any case, this is the layout that we're looking at. A variable squared, a variable to the first power, and a constant. Once you've done this, so this is your A. What is A's value if there's no coefficient? It's a 1, right? Your goal now is to find factors of whatever A times C is with a sum of whatever B is. What do I mean by that? Can somebody tell me what 1 times 28 is? 28. I need to find factors of 28 that have a sum of B. And what's B's value? 16. Now it's very important that you recognize positive and negative matters. Factors of positive 28 with a sum of 16. Positive 16. Okay? So we know 28 can be positive 1, positive 28, negative 1, negative 28. We know it can be 2, 14, negative 2, negative 14. 7, 4, negative 7, negative 4, right? Those are the factors of 28. There's one whole group that you can automatically throw out, and that's the negative side. Because the negative side are going to add together to give you a negative sum, right? Negative 29, negative 16, negative 11, when you add those together. You can automatically throw those out because they will not fit this part of the adventure. However, positive 2 and positive 14 do fit because they not only have a product of 28, but they have a sum of 16. Okay? Now, take the number 2 and the number 14 and place one next to each of these and choose which one it would factor the best with. Here's what I mean. The 2 can factor both with a 1 and a 28, but a 14 can factor better with a 28 because you can pull 14 out of both 28 and 14. So I'm going to place my positive 14 right here and my positive 2 right here. Okay? I usually draw this little line. Also, place the variable of the linear term next to each of those numbers. The linear term's variable is an x. Now, group and pull out anything that both pieces have in common. X squared plus 2x. What can I pull out of both pieces? That leaves me x times x plus 2. What can I pull out of both a positive 14x, and a positive 28? Positive 14. And what does that leave me with? X plus 2. Interestingly enough, you now have the same factor repeated twice. You see that? List it once, and then combine the other 2 in another parentheses, and you're done. You're all thinking this is really complicated. Trust me, it's easier than the method the book teaches you. You're now done. This process will become secondhand to you after you've done it enough times, I promise. Look for factors of AC that have a sum of B. We identified those. We place them in the middle, neighboring what they largest factor with. We pull out, and if we pull out correctly, then these 2 items are the same. Since they're repeated, you only need to list it once. The stuff that was being multiplied by that item gets joined in another parentheses, and you have your answer. Okay? It works for all of these. The next 3 lessons, this method works for. Y squared minus 9y plus 8. Pull down the last piece, positive 8. Pull down the first piece, y squared. Factors of A, C with a sum of B. Okay? A times C is what? Positive 8. Positive 8 has to have a sum of negative 9. What'd you say? I heard you. What'd you say? You're close. The only things that have factors, or that are factors of 8, is negative 1, negative 8, positive 1, positive 8, negative 2, negative 4, positive 2, positive 4. Those are the only factors that'll create a positive 8. On this list, which ones, when they add together, equal a negative 9? Per first one. This is a super easy one, by the way. Place these next to what they would factor closest with and add the variable. Negative 8y, negative 1y. Group and pull out whatever you can. If I pull a y out, y minus 1. I'm going to pull a negative 8 out. Negative 8. Oh, look. Y minus 1. These match. List it once. Combine the other 2 together since they both were being multiplied by the same thing. You're done.